Hello students, I am Malathy from the Department of Mathematics in SNS College of Engineering. Can you all guess the topic? Anybody have any guess which topic I am going to handle now? The topic is curvature and radius of curvature. Yes, today we are going to see that only. Curvature, the rate of bending of a curve in any interval is called the curvature of the curve in the interval. Note, the curvature of a circle at any point on it is same and it is equal to the reciprocal of the radius. The curvature of a straight line is 0. Can you all able to understand what I am saying? If we are having any curve like this, if you are having any curve, so this is curve, so from this interval, this is suppose if you are saying this as a, this is b, this is called the bending is called curvature. That is why I said the rate of bending of a curve in any interval is called the curvature of the curve in the interval. For the circle, if you are considering circle, the bending is common for all the surface. Suppose if I am taking from here to here, here to here, here to here, all are same. That is the thing I am saying as that curvature is reciprocal of its radius. Center of curvature. In geometry, the center of curvature of a curve is found at any point that is at a distance from curve equal to the radius of the curvature lying on the normal vector. Radius of a curvature. In differential geometry, the radius of curvature r is the reciprocal of the curvature for a curve. For a curve, it is equal the radius of the circular arc which best approximate the curve at the point. For the surface, the radius of curvature is the radius of a circle that best fits a normal section or combination thereof. So this is called the radius of the curvature. This is called curve. Circle of curvature. The circle with its center on the normal to the concave side of a curve at a given point on the curve and with its radius equal to the radius of curvature at the point. Cartesian formula for finding radius of curvature. This is the formula we have to remember, as we can write like this also. R equal to 1 plus y dash the square power 3 by 2 by y double dash. We always denote dy by dx as y dash, d square y by dx square as y double dash. So that's why I have converted the formula as 1 plus y dash square whole power 3 by 2 by y double dash. Shall we see one problem based on the radius of curvature Cartesian form? We have to remember the formula is 1 plus y dash the square whole power 3 by 2 by modulus of y double dash. This is our equation, y square minus 4x. Now what we have to do is we have to differentiate this equation with respect to x. So we are having here y square. So if we are differentiating y square means we will get here 2y dy by dx. So we can mention, already I said no, for dy by dx we can mention that as a y dash minus x differentiation is 1. So we are getting here minus 4. Actually what we will get is, if we are differentiating x means what we will get is dx by dx. It will get cancelled. So we are getting there 1. From this equation we can frame this y dash equal to 4 by 2 y. We can cancel these two terms. So we are getting y dash equal to 2 by y. Now we need to find y double dash based on y dash. So if we are having the variable in the numerator and the denominator means we can go for the formula u by v equal to v u dash minus u v dash by v square. But what we are having here we are having the variable in denominator alone. So what I am going to do is I can change here 2 power minus 1. So I can do the calculation as x power n equal to n into x power n minus 1. Here n is minus 1. So what we are going to get is minus 2y dash by y square. So this is the term for we are getting for y double dash. So I'm going to substitute y dash value there. So already we are having y dash value 2 by y. So I'm going to substitute. I'm going to get this y double dash equal to minus 4 by y cube. So now we are having the value for y dash and we are having the value for y double dash. Just we have to substitute in this radius of curvature. We will get the value of radius of curvature. So if you are thorough with this formula now, we can do the process very easily. We have to know one thing, that is basics of differentiation. You should know what is the differentiation, what is dependent variable, what is independent variable. So suppose if I am writing here dy by dx, this y is dependent variables, this depending this x. This x is an independent variable. So it is not depending any variable. So we can call it as a independent variable. So if you know these basic things now, we can solve any problem. Next one is parametric formula for finding radius of curvature. When the equation of the curve is given in parametric form, that is x equal to f of u and y equal to g of u, then this is the formula. Shall we do one problem based on the parametric form? Find the radius of the curvature. The parametric point is p of at square comma 2at on the curve y square equal to 4ax. What is the curve? Y square equal to 4ax means the curve is what, Kana? The curve is parabola. Yes. The parabola parametric is x equal to at square. We all know that x equal to at square, y equal to 2at. Now what we have to do is we have to find x dash, x double dash, y dash, y double dash. Here x and y are dependent variable, t is independent variable. So we have to find dx by dt here. So we have to differentiate with respect to t. So we are going to get here 2at. Then with this 2at we have to differentiate with respect to t again. So we are going to get 2a. Then what we have to do? We have to do y dash. In y dash you will get here 2a. In y double dash you will get here 0. Yes. After get all those values, just we have to substitute in this value. Then we have to find the final value. Final value. Why I am using here modulus means radius of curvature never be in negative sign. So that's why I am using here modulus rho. So always we should remember radius value we never attain in negative sign. Next is implicit formula for finding radius of curvature. So this is the implicit form fx square plus fy square whole power 3 by 2 by fxx fy square minus 2 fxy fx fy plus fyy fx square. Yeah. So we are going to do one problem based on that. This is the equation at the point 0, 0. So we have to find fx. Fx means what? We have to do the differentiation. We have to do the differentiation based on this equation with respect to x. First of all, we have to differentiate x alone. So x cube is 3x square. Here we are having x, that will become as 1. So 3y square. Here we are having x square. So 10x minus 6. Likewise, we have to go for fy. fxy means we have to differentiate this equation with respect to y. Fy means we have to differentiate with respect to y. Fxx means we have to differentiate this equation with respect to x. So here we are having the point as 0 comma 0, so there is no issue, we need not to substitute in anywhere. Suppose if we are having any other point means we have to substitute there and we have to go for the formula. So 0 comma 0, so wherever we are having x we have to give 0, wherever we are having y we have to give 0, then we will get all those values. After get all those values, just we have to substitute in our formula, we will get this formula. Finally we will get this value. In this also, if we are getting negative value, we have to put modulus for that also. Thank you.